Okay, so we'll first understand about sets in Python. Okay, in the last class we have discussed about the tuples and list and conditions. So today we'll be understanding on the loop structures and the set data type. Okay, so set is one of the other data types we have seen in the data type list of Python. Okay, and it can to store number of elements. Okay, it is again you can say a collection of data elements, right? But there are some important facts about sets, like you have to store data in a unique manner, or you can say like the set actually stores data in some unique way. Suppose if I say x is equals to gonna be 34, 56, 78.5, a d 32.3, j, a lot of things like this. So if you just try to see again I for, I'll just write type of I for I in x, so you can see it's complex, integer, string, float, integer, string, and so on. Okay, so we are getting the different type of I, whatever it is, right? We are getting all those different types. And the thing like is, when I am going to print the x, it is getting printed in some other order, right? So you can see like the orders are not exactly maintained as being given input, right? That is the first thing you have to see, that order is not maintained. जैसा आपने दिया था in the same order you are not getting as the output. Okay, so it's complex first, then 34, then d, then 78.5, then 56. So basically when you go for a definition of sets in Python, you say collection of unordered elements. Okay, right? And that is the reason, due to this unorderedness, you can't do any indexing things there, right? So you cannot do indexing, and though you can't do indexing there, so you have some sort of operations which you can do and set. Okay, so we'll be going, oh, so you have clear, add, copy, difference. So suppose mathematically, or in computer language, or in programming language, whatever you take it, suppose we have a set A, I'll term it as S1. We have set A, B, C. Our set 2, which is named as D, E, F. Right, very simple. So first we are gonna see adding sets. So two sets to add, when we try to add two sets, how we're going to do is S1 dot add S2, and simply if you just look into S1, so okay, if I perform this operation, right, what it's saying, unhashable set 2. Anyways, I'll just update it. Oh, okay, so we are using set 2 to add it, no? So that is why we have to update the elements in the set 1. So this is when you are taking multiple elements, like in list we did now append, and there was extend, right? So to add one element and add multiple elements at a time. Similarly, in sets you have to add one element and multiple elements in a set at a time. Okay, so that we can do it very simply. So if I just now look into S1, you'll find A, B, C, D, E, F over there, right? Okay, so it's A, B, C and D, E, F, very simple, right? But if I want to add only one element, I can just have it add, suppose I want to add 23 to it, or a D to it. So is there any change going to happen? No. Why? Because set only stores unique elements, and since D is already there, there's nothing to be given reflective right there. Okay, so this becomes A, B, C, D, E, and F, simple as to be. Okay, now moving to next, this S1 can have a lot of functions, and some mathematical functions. We'll be going through it now. Simple mathematics, class 11, right? Union, right? We know what is union. Yeah, S1 dot union of S2. Another approach could be S1 union S2. Another approach S2 dot union of S1. What it means? Anyone who can tell? क्या होता है union? ठीक है. Collection, actually it's combination of all those whatever you have given in the sets, right? Yes, no, है ना?
Yes, sir.
So this is simply your union. Next is intersection. We have been using this symbol a lot of times. Intersection, what it is? Yeah, S1 and S2. If I write like this, I get D, E and F. So that means, let me just check it out. S1, if you check S1, it is A, B, C, D, E, F. And if you check your S2, it is D, E, F. So in between S1 and S2, what are the common things, the common elements in these things, in those sets actually is D, E and F. So that is what you are getting in D, E and F, right? I believe that's simple, easy to understand. Okay. Rest, like, you can also go with the intersection part, and you can have S2 intersection with S1. So with S2 also you'll get the same thing. So you can have and also you can have this. Next is you can see the difference between the elements. Okay, so difference can be made as S1 minus S2. So all the different element in set 1 which is not there present in the set 2, so that has been mentioned, similar to S2 minus S1. Okay, so it's an empty set because in S2 there is something, not exactly any element which is not there in the set 1, so everything is there. So we can call S2 as a subset of S1. Okay, we can call that. Next is you can make this same thing using difference. S2 getting same thing again. Alright, so these are some of the basic things you can check for. Next we go. Now you get discard, you guess its subset, get updation methods, is disjoint, pop, remove, union, and things. Okay. So next moving to remove elements. So in S1, if I say dot pop, it will just simply move any element. As you know, S1 pop function, what it does. So A, B, C, E, F is there, D is removed, right? Similarly, if I want to remove something, I'll just write S1 dot remove, and I'll say I want to remove C from here, and I'll check my S1. I'll see like A, B, E, and F. But there is some more interesting function named as discard. What is going to happen in discard is if I say S1 dot discard, if I say G, so it is not going to raise any exceptions or any outputs or any errors, you say error outputs to you. And the reason for this is like, because if the function working, I'm saying, right, if the element which is being mentioned, or the, you can say, parameter which is being mentioned in this, if it works, it's fine, right? That means if it finds that particular substring or the element what you have written, if it is there in that set, so it will remove it. If it is not there, then it is not going to raise any exceptions, any errors for you, right? So it just leaves it just works like a comment over there then. Okay, so it just simply pass the things, that's it. Now what if the element is found? In that case, it is going to remove that element. So D is still not there. E, okay, so you can see E has been removed. So that is the approach that it follows. Well, okay. Next. Next is copying a set. That is simple. S1 dot copy you have to do. Your sets will be getting copied. Well, that is also fine, I guess. Updations are there in sets, intersection update. Then you have union difference update. Apart from all these, now this S1 and S2, if you look, we have ABF and DEF. Okay, only F is being common now. Now suppose if you want to see the uncommon elements, so uncommon elements in the Python sets, how you can find it out? Can we have a way how you can find uncommon elements in both the set?
So union of both set minus intersection of both set.
So you're going to do union of both set minus intersection of both set, right? Club, you have done this. Now you want to find the uncommon elements, that is this minus this, right? You're saying this. So you're getting A, B, D, and E. A, B, D, and E. But in Python, if you want to go with, anyways, this is a correct way in mathematics, right? But in Python, if you want to go to find the same thing, you have a function called symmetric difference. Okay, symmetric difference between set 1 and set 2. The same thing it is going to do actually. So the function working is this only, right? You first have to write the first one, which you have to use the second one, and then it just does the same thing what you have said. So the background working is this, okay, but the front end what you see is this one function, right? Okay, so we'll move to the next part. Now is something called is subset. Now suppose we create a new set S3. It's having this, right? Now D and E are also present in, let me just check, second set, right? So I want to just check and say, if I just say that S3 is subset of S2, how we'll find S3 is a subset of your S2. So you're gonna get it true, right? Okay, so you're going to get it for true. The same you can just go for a reversing thing, that is S2 dot is superset, and you're gonna have S3 over there, and that comes true. So the correlation is of a subset and a superset over there. Okay, so if this is a subset of another set, then ultimately you can say that if X is a subset of Y, then Y is a superset of X. Simple. Okay, so that is all superset and this. Now suppose that we have S1, we try to find relation between S1 and S3. So S1 and S3 relation, what it would be, S1 dot, if we go for checking of is disjoint, this is tell this is actually telling you true, right? So the relation between S1 and S3 is null, or you say disjoint. So disjoint means they don't have any common elements in between. Okay, if we just look onto S1 and S3, they don't have any common elements in them, right? So that is, they are disjoint. Sorry, disjoint. Okay, so that is what is in the sets part. So we have done with the functions, I guess. Now going with the update functions, what it is. So suppose you did the intersection or difference, whatever, right? If I'm writing, so if you just write s1 dot difference in s3, you get values, but it does not change your s1 and s3, right? You are getting the values of s1 dot difference of s3, but it is not changing those values, right? But what if we want to change it? Okay, so we're gonna do s1 dot, that difference it is. So what you want to update actually is that whatever the difference you are getting between s1 and s3, you want to update it to s1 itself. So I'll tell for s1, sorry, s3. So this is not going to give any kind of outputs to you, but when you check for s1, you will get a, b and f. So that is what is you were getting in the difference part here is now updated in s1. Okay, so your s1 is changed. Okay, for example, here we cannot say like exactly changed, because s1 and s3, s1 is obviously having abf from previously as well. Okay, if you take the difference, still they are having that same thing, so it is not changing. But what we can do is we can change the s3, and then we can do the same thing again. Okay, so we can say s3 dot add f, and s3 becomes def, and our s1 was a, b and f, right? So if you run this thing now, you get only a and b. Why? Because now f is also there in s3 and also in the a. So now you are getting a and b. Okay, so it is not changed, I believe. A, b, f, d, e, f, right? Let me just update the differences, and I'll check my s1 again. So you can see now that s1 is only storing a and b, as the difference has been updated directly to s1. So the first element what you write is going to be updated. Now let it be a union, or let it be a difference, or any kind of update you are going, symmetric difference update or whatever. Okay, so symmetric update, if you do with as3, again s1 is going to change. So it was ab something, now it becomes def as per the symmetric difference. Okay, that is how it goes. All right, so here we complete our sets part. Okay, so getting next into the loops, we'll understand about how these loops are going to play a vital role in programming things. Okay, so loops, first of all, like if you define and understand it, it's nothing like just like an iterative process what you have to do again and again until some certain you can say conditions are being met. Okay, now when conditions will be met, based on the statements you write in the programs, right? So there can be two kind of conditions. One is indefinite and one is finite, right? Indefinite, that means that you just write the conditions, you don't know how many times the loop is going to run, but at one time it is going to stop, right? I'm not saying about infinite loops, indefinite and indefinite and definites. Okay, infinite lookup, something which is not going to stop, obviously, right? Okay, So when you don't know that how many times you have to execute a loop, what is the number of iterations it is going to follow, then we use while loops. And when we know that how much number we are going to execute, what is the number of iterative process we are going to do, that are called as for loops. Hmm? Well, we'll be dealing with that better way. Alright, so first we'll be looking into the while part because it comes very easy to understand, and the loop control statements will be taken in. Okay. So last class we have done conditions, no? So in conditions, what you have gone through? If, else, and elif something, no? Okay. Okay. Well, let's go with the while loop first. Now, when I define, like, when we don't know number of iterations, what we have to do, we'll define while loops, right? But number of iterations we don't know, but we know that as long as the condition is going to be true, the loop is going to execute, right? So the while loop executes as long as the condition is true. Now, these things are fine that we can go with for and while. Now, what is the need of loop? For everything, we need to understand it. What is the need of doing this? What is the need of that particular data type we have learned till now? What is the use of lists, tuples, and sets? Why we use different data types, right? So, what is the need of the loop? So, suppose like you have a problem statement. Okay, suppose you are the owner of a college or institution, something, right? You have 1,000 students in your college, school, and you have to make a program to calculate the percentage of the students, right? Percentage is like of whatever the marks they have obtained for a year to declare the results, final results, right? So if the same scenario is for a tuition teacher, right? Okay, suppose for a tuition teacher who is having 4 or 5 students, okay, there will be a process difference in that mean that they both be calculating the results, no? Tuition one also will be taking some sort of results, school one will be taking some sort of results, but they both will be taking out their results in different patterns. One will be doing manually and one have to do it through machine, right? Manually, if they're going to do, it will take a lot of time, right? If you are running a big business, right, if you are in business, right, and you're going to do a lot of things, you have to do a lot of things in one single step, there is something you need to be done which can do it very quickly and accurately, right? So that is where your iterative process loops come in. So you are not going to take that algorithm of calculating the sum of marks obtained divided by total marks multiplied for one student. One percentage got, second student same thing, third student same thing. No. So what you're going to do is you have made that logic. You will put that logic in a function. You will apply that function to your complete database, and all at a time it will be done. That's a simple step. Tuition teacher can take 3 4 students are there, no problem, calculate marks, divide by number of total marks and multiply. So for 4 5 things it's fine, but when it is in mass, right, you have to make it done through machines. Simple. So that is where the need of the loop comes. Now it depends on what kind of looping you are using. So for while, what is the syntax? Anyways, in your LMS, a lot of things of assignments are there for the while loops. I'll just walk you through with some sort of more files we have. We'll check it. So suppose if I want to print the values of I, as long as I is going to be under some sort of values, a simple program, print the values of I as long as I is less than 10 20 30 something. Okay, so you require, till now we have been doing for loops, list comprehensions and all what we. So first I'll initialize it. Suppose I is equals to 1. I is nothing but, as I initialize it, a counter method what we'll be using in the loop. In the past classes, whatever we have done, right? So while I is less than equals to 6, because I have said that as soon as I becomes 6, I'll come out, right? Not only I is less than 6, right? But I will check for as soon as I becomes 6, I'll come out of the loop. Or if you want, we can just take it for this one, that I, as long as I is less than 6, that's fine. Okay. So what is going to happen is I is equals to 1. Now we're going to check that while my I value is less than 6. So for now I value is less than 6. That's correct, true. So while it is true, you go for the operation written. So you have to print the I. Once you have printed, you will initialize this as equals to 1. If you don't do, what will happen? Again I will be 6, again I will be 1, sorry, right? I will be 1, and 1 will always be less than 6, and it will keep on printing. So it becomes indefinite, right? Or you say like it becomes infinite loop. Okay, so we have to put up the assignment operator and with 1, okay, so that it goes again back and it becomes I now as 2. So 2 less than 6, 3 less than 6, 4 less than 6, 5 less than 6. Okay, and 6 equals to 6, when it will come, it is going to stop. So what we are going to do is, after this, else we'll write I reached 6. Execute it. You see 1, 2, 3, 4, 5, and I reached 6. Okay. So 1, 2, 2, 3, 4, 3, 4, 4, 5, 5, 6. So you can put a number of iterations you want in things simply. Okay. Fine. So this is a simple program of while loop. So I'll take you through some of my, just let me check it if we are having it here. Loops. Okay, fine. We don't have it here. Anyways, fine. Thick. So this is a simple program of while, right? With for, you can go with the same thing, but you know that number of iterations to gonna do. Okay. So you just put a condition here. You don't know that how many times I'm going to get the outcome. Since I is less than 3, it is going to print and initialize again and again and go to do a lot of stuff over there. But how many times it is going to do the same thing, right? So that we don't know. That is why I say it as indefinite loops. Okay. So there is a complete structure, I guess, made for loops. I will check it in which file it is, then we'll go with. Okay, now coming with the for loop. Okay, so when we talk about for loop, we are here estimating, or you can say the values what is going to come, because you actually see in your data type the sequence whatever, because for is such kind of a loop which is used to iterate over some sequences. Let it be a string, let it be tuple, a list, or any other iterable objects. Okay, so iterating over sequence can be a traversal methods as well. So same thing, we're going to go and write it that until I is less than 6 value, and just want to get values in for. So suppose you write for I in, now you know that what is the range, 1 to 6 plus 1, right? Ranges we have learned. So I'm gonna print I, simple. So 1 2 7 for I in, oh, we forgot to mention range, 1 2 3 4 5 6. So here till 5 we are gonna do, huh? So 1 2 5 simple, and after that else we are gonna write it I reach 6. So this we have done, no? So your I reached 6. Simple. Okay. So with this, we have seen a lot of examples of for in the previous classes of, I believe, right, for loops, taking out sum, taking out to find the sum of all numbers stored in kind of a list. Okay, right. If you want to store it, let me just check. Suppose you want to make a program to find sum of all numbers which is stored in a list. So there are a list of numbers 6, 5, 3, 8, 4, 2, 5, 4, 11. Okay, now to find the sum of all these, right, you have made a variable like sum. Okay, and that is 0. So you are gonna iterate over the list. Now what is going to happen for val in numbers, all the values are lying in the numbers, right? So you're going to take sum equals to sum plus val, or just put it like this. Okay, what are the values you have, you just add it with the val part. So for value in numbers, sum is going to be 0 when 0 came, or no, like it is 0 for now. So 6 came, 6 plus 5, then adding more to 3, then 8. You know, like the cumulative frequencies, cumulative sums and statistic parts, right? Simple. Okay, and these are widely used in these kind of data, you know, stock market investing and all those simple things. So I'll just check for like we have any stocks data set. I'll show you exactly how it is made. Well, that we'll do after this looping understanding. Go for some practical applications. Okay, so you can iterate the program or any sequence, okay, using some sort of indexings as well. Okay, now indexing can also play an important role, like we'll be doing dictionary in some coming classes, right? So we'll be looking at like suppose I have to make it one. Suppose A is 45, and we'll deal with it tomorrow, I guess, right? B is 56. Okay, these are dictionary, and I just say for I in your D will print I. So we're getting A and B. Instead of A and B, if I want the values of I, like what this A and B are storing, I'll have to write like this, and I'll get 45 and 36. So indexings can also be done in for loops, you know, to have a better understanding. Okay, so I just looking for that particular, what is that file name? Let me just go and check at some sort we have it. Yeah, so to process the functions of the loop, the, you know, these, where at what point of iteration it should stop or it should skip that part, right? There are a lot of things where you need to skip the values as well. Okay, so those are called loop control statements, where you can handle your loops in some structured way as well. Okay, so in Python we have 3 control statements, where the last one is not going to work any kind of thing, like that is just for when you are working on some projects, you know, you want to fill the spaces of that, so you use pass. It just acts like a comment. Okay, it is not going to give any output, not going to affect your code as well. Okay, so basically if you just talk about it, you have 2 important control statements, break and continue. So break is something which is going to just terminate the loop. At that point, wherever it finds break, wherever the program finds break, it will just stop, and after that it's not going to execute again that particular code. Okay, it will come out of the loop. Continue is something like wherever you find continue with the program, that particular code is going to be skipped. We'll do this and check for this. Okay, so while loop will be indefinite or conditional loops. Okay, they will be iterating until a specified condition is being met. Okay, and there is no guarantee ahead of time regarding how many times the loop is going to ahead. So this program we saw again. So let's just make a simple program of guessing numbers. So what we are doing is importing random, and from random we are just bringing random numbers between 0 and 1, okay, through random dot random function. Although we are having this in math and which class, modularization and math class, I guess, right? Next, number guessing. Now you just have to understand the problem, okay? So what we are doing is we are taking these random numbers. Now what if we multiply it by 10? These numbers, when it is generating, see, when you multiply it by 10, it is coming something like this. Instead of between 0 and 1, those decimal values are being multiplied by 10 and it is giving now values like this, okay? So what we are going to do is we'll multiply it by 10, and whatever now it comes, if I multiply it by 10 and it comes some in decimal numbers, I'll take integer of that, okay? So after taking integer of that, just add with 3. So sometimes suppose 0.3 comes, then the integer part will be obviously 0, right? And 0 plus 3, so that it can be 3 at least, because our numbers are not going to come from 0. Okay, so we have to be taking care of everything what we are going to mention. Okay, so there is a variable guess equals to 0. So while your guess is not equals to number guess, that means until and unless your guess does not match with the guess what machine has made or what the number machine has generated, right? Until and unless they both are equal, you keep on going for the iterative process. Okay, this process will be done, this complete part. But what if your guess is correct in the first round itself? Directly it will print congratulations, you guessed it. Okay, now the second thing, what if your guess comes wrong? You will ask for guess again. Okay, it will again tell the number, like you will again tell the number whatever it is. Again it will check if guess is greater than 0. Okay, after the guess is greater than 0, you are going to check whether the guess is greater than the number guess also. Clear? The number guess, if it is greater than number guess, whatever you have guessed, then it will say the number is large, you are very far from that number. Okay, or a little far, whatever it is far, but you have made a larger guess, come down, right? And if you make it less, the number is less. And if you enter anything else between 0 to 9, leaving a 0 to 9, if you enter any kind of thing, it will just say invalid input, and it will just come out of the loop from that particular place. Okay, so let me execute it. New number, I'll just say 5 to 8. Okay, so suppose 5. Okay, it's saying number is large, so that it means that I have guessed a larger number, 3. Alright, so I made it in the second attempt, so it says that congratulations, you guessed it. Okay, this is how it gonna goes. So you need to iterate the I here, that is what it goes. Okay, now with for loop. So for loop is going to execute statements for each and every other sequence you have made it. So every element is going to print one by one. So unlike while loop, we already specify the number of times the iterations is going to happen, because we know that how many numbers are there, how many elements are there in our sequence. So days, suppose Sunday to Saturday. For x in days, print x, simply have done. For elements in this. Now what happens when we do multi-indexing? In a list, we have one list and we have another list as well. Okay, so in multi-indexing, what is going to happen? It is not going to print 1, 2, 3 again and again like that. No, right? Because that one list and second list inside a big list is considered as two different elements. So that is being printed, right? So we're looking into the NumPy library when we'll go through this. Otherwise, you can just go for I, j in I and j. You can just go for zipping of the elements to bring it 1, 2, 3, 4, 5, 6 like that. Okay, range functions, so we have seen factorial program. Okay, so a simple factorial, if you know factorial of 0 is 1, 1, 2, and so on. No, factorial, how it goes. Suppose if I 4 factorial, if I want 4 factorial, it just goes 4 into 3 into 3, 2 into 1. That's simple, I guess, right? So everyone knows about this. Until like till 1 it goes. So we are going to make the same program here. Factorial is equals to 1. Now if by default we have stored factorial 1, okay, we'll take the number. Now if the number is less than 0, it's a simple invalid input. We are not going to take factorial of that particular number. If it is equals to 0, factorial will be just 1. And now if it is not less and not equals to, that means obviously greater than 0. So for greater than 0, for I in range of 1 to num plus 1. Now I guess why we have done num plus 1, you can understand, right? Because the range is going to take 1 minus of the less whatever the stop you have written. So if you want 5 factorial, so it will take 1 to 4, not 5, right? So we have to make it 5 to plus 1. So factorial will be equals to factorial into whatever the values they're getting. You just multiply it, keep it multiplying by I, whatever your I comes. So for I in range of 1 to 5, suppose. So 1 into 4 into 3 into 2, whatever it is. 2 into 3 into 4 into 5, like that. So, and keep it storing it like this. So I say number 5 factorial 120, number 0 factorial is 1, number 2 factorial 2, simple. Okay, that is what it takes. Now break, continue and pass is to be applied. So suppose you are taking this structure, this sequence 2 3 4 5 6. Now if your I becomes 5, you just simply break that particular place and print the numbers. Loop ended, execute it, print numbers. Number is not defined. Oh, you just have to go with this I. Okay, so 2 3 and 4. All right, for numbers in this, if number is equals to 5, continue, print numbers, end again. So here break, you see 2 3 4 breaked, 5 and 6 not printed. Here 2 3 4 at 5 continue, so 2 3 4 and 6, 5 not printed, skipped part. Pass is not going to do anything. See, 2 3 4 5 6 end. Now a simple program to understand about the loops so that we can find up the session. Okay, so this is a simple program where what we are going to do is, so dictionary will be understanding tomorrow, so I'll make you understand this same program tomorrow again. Okay, so what we are going to do here is, with the help of loop, you will be able to generate these kind of outputs. Okay, output in the sense like it's just a simple program of passenger record generation or record maintenance, you can say. So what you're doing is you're making 3 lists. Traveling, input yes or no. So if you are traveling yes, you'll enter the number of people, and for the number of people you will enter num. Okay, it is going to take that in loop. So for num in range of 1 plus num plus 1. Okay, suppose 2 people you are traveling, so 2, if you write inside here 1 to 2, it is going for run only for once, no? So you have to mention num plus 1 there, right? So name becomes input, name of the passenger, and obviously I'm going to split it 0 because I want to take only the first name, right? I guess these things we have done, no, in strings. Okay, dot append age equals to, just take input of age dot append age. All these lists what I have made, I'll just keep on adding on the names and things over there. Okay, I'll print details, name, in age and gender, and after that we'll print that confirm entry yes or no. That means that your entry is being yes or no. If you again write yes or no here in the traveling, if confirm entry means that you are not traveling with any more person, or if suddenly you are thinking of traveling with anyone else, you'll write yes over there. Okay, so if you write here no, that means simply you will print this particular information, passenger data, zipping up all of them. Zip we have understood, right? Combining the elements of the sequences in an iterative process again, and the data type mentioned in that. And this is the dictionary part for data. In this you're just taking the index values. So this 2 lines I'll explain you more on tomorrow after learning the dictionary part. And here if you mention yes, so traveling will becomes yes. Once traveling is yes, again it will ask for the number of inputs, because once traveling become yes, it again asks for the number of inputs, and you go. So let me just hit enter. So you're traveling, so if you write no, what is going to happen? Passenger information, nothing, right? So if you say yes, I'm traveling, enter number of people 2. So I'll say name of passenger. So I'll say Sean, age 21, gender male. Second, Mickey, age 32, gender male. So it has printed. Check your details, Mickey 32M, and check your details, Sean 21M. So after every entry, it will tell you to check all the details in the pattern it is storing, so that this is the pattern which is going to reflect into the ticket or something, right? So confirm your entry, yes or no. So I confirm yes, and oh, I have mentioned yes again. Anyways, so I'll just add one more. So I'll say it as Daisy, age 20, female. Confirm entry, yes and no. So no, don't want anyone else. So passenger information, passenger 1 Sean M21, Mickey M32, Daisy F20. Simple. Okay, so you can make a data frame or a data set of it again, but that is something we'll be learning slowly in the upcoming classes. Okay, so that's all, right? I believe this particular thing is clear to you. Yeah, any doubts to anyone? Yes?
No, sir.
No? Okay. Let me just stop it.